Hello everyone, my name is Satyam Nilmani and today we will be starting with the second lecture of statistics for PGDBA interview preparation. So in the first lecture yesterday, we completed on the topics about what is statistics, and I gave you three assignments in the form of activity. First was that you have to note down your education background, work experience and hobbies. Okay, and then the first activity was you have to create one story of yourself. Okay, one story from the education background. For example, I am an agriculture engineer, so I will be preparing one story that how do I think the knowledge of machine learning, the knowledge of analytics, the statistics can add the current technology, current processes or current methods which are being practiced in this particular engineering. You may be coming from the medical field, you may be coming from the commerce field, you may be coming from a different academic discipline. So prepare one story from this side. Second, I ask you to prepare one story from your work experience. For example, prior coming to PGDBA, I worked in the healthcare sector. Okay, so I will be preparing one or two stories. My understanding that how do I think the stats can help the businesses, the stats can help the healthcare sector. Similarly, prepare one of your hobby and try to think how the knowledge of stats can help you in making more mature, more optimized decisions. Okay, and to prepare these stories, you are not required to have a very in-depth understanding of the stats. You should know, okay, this kind of analysis, if I'm already having with me, so I will be able to take a better decision, better call. Okay, and whatever the statistics knowledge that is required to formulate these stories, we will be covering that much stats in these sessions. Okay, and the center of the whole session will be to qualify the PGDB interview. Okay, and these lectures will not be too academic, they will be more applied side. Okay, and taking the inspiration from the type of question that have been asked in the past 10 years. The second activity which I have given to you was something similar, and you have to take any one company, startup, or any mobile application you are seeing in your device. Prepare that what kind of data they can collect, what kind of insights they are actually presenting, what are the challenges do they face, okay, while collecting, reporting, analyzing, and presenting these results. Okay, prepare these stories, and once we would have completed all the 9 sessions in this stat, then we'll try to figure out how can we give the hints to the recruiter during our introduction or during some other statements that the recruiter becomes curious to ask the question from this side. So in this way we can actually steer the questions for the interview. Okay, so I've also mentioned few interview problems here. Okay, one thing, since this talk will be available with you, so you are required to highlight the important keywords, the technical keywords here, and it will be good that if you use those keywords in your answers, in your expressions. Okay, so we had completed this session till this data versus information versus knowledge. Okay, till this part we have completed this session. Today we will be coming to the types of stats. So stats we have already studied is nothing. It's a kind of science. Okay, science of collecting, reporting, presenting, okay, analyzing the data. It is the language of the data. Okay, now the statistics can be of two types. It can be of descriptive type, it can be of inferential type. So this kind of question, it can be asked to you in the interview. So if they ask, they will be asking how do you differentiate descriptive versus inferential. So these are the 4 points you can keep in mind, that the descriptive stats actually summarizes the data and describe the data. Okay, and when I am summarizing the data, it means I will be using the whole data. Okay, but while I have to draw some inferences, okay, inferences as of now you can take it as predictions. Okay, although prediction may not be the exact right word to understand inference, but the intent of using the word prediction will be helping you to what do we do the inferential stats, okay, closely. So what happens in the inferential statistics, we try to predict. We are never using the complete data in the inferential statistics because of two reasons. First, either the complete data is not available for us to compute. Okay, whole data is not available. So complete data is not available. First reason. Second thing is, although if I am being provided with the complete data, I may not be in a position because I may not be having those technical resources. I may not be that much efficient to compute whole data. Okay, so I may not be computationally efficient. Okay, handwriting is little bit poor, but I think you understand, computationally efficient. Okay, sometimes drawing the statistical measures on the complete population data is actually not very much efficient. Okay, in those two cases, either whole data is not available or I'm not having those resources with me so that I can do the calculation on the whole data. So I'll be going with the inferential stats. If these two challenges are sorted, then I will be going with the descriptive data. One thing, since I am using the complete data in the descriptive stats, so the results in the descriptive stats will be exact. But in case of inferences, since I have used only part of the data, so in that case, what will happen? My results will not be exact, and my objective will be to present a result that is close to the real. Real means if I would have used the complete population data. So whatever the results I'm getting from the sample data, it should be close to the population. Okay, so here what I am actually presenting the results in a kind of interval. So these are the terms: confidence interval, regression, hypothesis testing. They are actually more associated with our inferential stats. We'll be studying them later. When we do the descriptive stats, we have median, mean, mode, range, standard deviation, and graphs as well. Okay, and the probabilities, prediction, conclusions. Okay, so these are the technical words which are associated with the inferential stats. Okay, and entire data is being used in the descriptive stats, sample data is being used in the population. Okay, so these are the 4 or 5 pointers you can keep in mind. Okay, I think they are very straightforward, and we will be discussing 2 or 3 sessions on the descriptive stats, and more sessions will there be on the inferential stats. So if I give you one example about the descriptive stats, the recruiter can ask, can you explain me the descriptive stats through an example? So if such a question is coming to you, then you should answer that example which have an impact in your life. The impact in your life is coming from your education background, hobbies, uh, your work experience. Also, there is one great skill. If you could randomly generate one example observing the atmosphere of your interview room, that can also be a very smart way to describe the situation. So suppose if the recruiter is asking an example of descriptive stats, what can you do? I have taken here the reference of the company Zomato. Okay, so we will be analyzing the monthly sales of the Zomato. So for the month of January, the sale was of rupees 10 crore. For February, it was of 12. For March, it was of 15 crore. If I have to take the average of the first 3 months, January, Feb, or March, okay, it's a quarter one. So the average sale will be 12.33 crores. Okay, so it is describing me, it is summarizing me the sales of first 3 months. And descriptive stats actually kind of representation, okay, or representation metric, kind of representation metric of a volume of data. Means 3 months of data is being represented by a single number. Okay, so that is a kind of summary. So this can also be presented through bar graphs. We will be studying the visual graphs later. And so this is a kind of summary. We will be studying the different measures of summary, mean, median, mode, central tendencies, everything in detail later. But the objective of this example was to make you understand what is the meaning of the summary. Summary means here I'm having one number through which I can do some benchmarking, I can do some analysis, I can understand the situation of the business. Okay. Now coming for the inferential stats. Now in inferential stats, suppose Zomato wants to launch a new feature and runs a survey of 1,000 users. There are millions of customers of Zomato, but if they have to launch a new feature, they cannot ask every customer about that feature, will they be liking it or not. So what they do, they randomly select 1,000 users. This number is random. It could be 1 lakh, 1 million or anything. Okay, they randomly select a small pool of people which can represent the whole population. And based on the analysis of those features, they will be drawing some conclusions. Okay, whether we should include this feature or not, or what further we can do with the product, or whatever the feedbacks they are getting from those users. Suppose out of these 1,000 users, 720 said okay, they're okay with the new feature, they will be using it. So Zomato will be inferring that okay, 72% of its total user base might like the feature. Okay, although they have not used their all the customers, but they have taken the sample of 1,000 users. Out of them, 720 said yes. Now they are saying 72% of the total user base. Okay, so they have uh, uh, said that these 1,000 users are actually representing their millions of users. Okay, now how are we sure that these 1,000 users are actually perfectly representing those millions of users? So these kind of questions are actually being dealt in sampling statistic. Okay, they are the different ways of sampling. So while doing the sampling, please make sure that whatever the sample we have collected is actually representing the whole population. Okay, so here we try to infer, we try to predict, we try to uh, generate a result which is telling the story about the whole population without using the whole population into the calculation. Okay, now the activity which I will be giving you here is prepare one use case of descriptive stats and one use case of inferential from your academic background, work ex, and hobbies. Okay. Sample versus population. So here, this population is not the people. Okay, the population can be anything. Okay, suppose if in a tree, in a forest, there are 1,000 trees. Okay, so that 1,000 trees will be the population. Okay, in a school, there are suppose 500 chairs. So those set of 500 chairs will be considered as a population. Okay, so population is a set that is complete in itself. Okay, and that completeness will be defined by the stakeholder, the person who's interested to do that analysis. Okay, so this is not the population of you and me as a people, as a human. Okay, this population can be of living things, non-living things. Okay, and this population can be finite and can be infinite. And if I take any part of this population, that will be called as sample. Okay, suppose the population of Delhi, if I assume it to be 1.2 CR. Okay, I'm not sure about the exact figure, but I am assuming that it should be close to 1.2 CR. If I have to draw a poll that to which political party do you support? Okay, so I will not be doing a survey on all these 1.2 CR people. I will be taking a sample of say 1 lakh people. Okay, and based on the survey results of these 1 lakh people, I will be calling it okay, the whole population of Delhi is supporting this political party. So these kind of inferences may be used by the news channels. Okay, so whenever the statistics you are seeing in any news, that is means not likely to be applied on the whole population. They must have applied some these kind of statistical methods. Okay, now there are two keywords. One is the statistic, one is the parameter. So statistics, statistic, this is actually the numerical character of the sample. Okay, means what is the numerical character? Numerical character could be the mean, median, mode, standard deviation, variance. So these, and there can be many. Okay, I have only named a few here. So these numerical character If I am using a sample, so it will be termed as statistics, and parameter is the numerical character of a population. Okay, for example, sample mean and population mean, both are different. Okay, so sample mean is a kind of statistic, population mean is a kind of parameter. Okay, the symbol for the population mean we use as mu, for the sample mean we use x bar. Okay, these are the standard notation. It is likely, I mean, very least likely that they will be asking these notations, but they may ask you the definition. Okay, whenever the parameter word is being used, it means the numerical character, whatever would it be, it is about the population. And when they are using the word statistics, so it means they are speaking about the sample. Okay, so we have studied till here about the type of stats, descriptive and inferential. What is the difference between those two? And one example of each. And you are required to prepare one personal example on the descriptive stats and the inferential stats. The difference between sample and population we studied. Now coming to the type of variables. Okay, so the variable is something that can have a different values. Okay, that is not constant. So in the statistics, we can define variable in two ways. One is the qualitative, another is the quantitative. Okay, I'll be telling you about the difference between these two in little more detail. And there are four scales of measurement: nominal, ordinal, interval, and ratio. So what are these? Suppose I have a data. Data can be of two types: qualitative and quantitative and qualitative. So qualitative data is that data on which I cannot do any mathematical operation like plus, minus, multiply, or divide. That data on which these operations are not applicable are coming in the category of qualitative. Okay. So for example, if I gave you the name of three cities, say Delhi, Mumbai, and Pune. Okay. And now I ask you what is the average of Delhi, Mumbai, and Pune. Now you will be saying, okay, what is the meaning of doing the average of Delhi, Mumbai, Pune? I mean, it should make more sense. Do the average of population of Delhi, Mumbai, and Pune. Okay, do the average of the trees present in Delhi, Mumbai, and Pune. That made sense. But if I'm saying what is the average of Delhi, Mumbai, and Pune, it is not making any sense. Okay, because if I write Delhi divided by Mumbai, what does it mean? Okay, it does not have any meaning. So it means in this type of data, I cannot apply the mathematical operation. Can you say that Delhi uh, is more than Mumbai? No. Okay. Can you do Delhi raised to the power Mumbai? No. So this kind of mathematical operation I cannot apply here. That's why these are the qualitative data. So there are two kind of qualitative data. One is the nominal. Nominal are those data where I cannot do any kind of mathematical operation, any kind of relativity is not available. Okay, the only analysis I can do is of frequency. How many occurrence of one category? If I call it to be one category, if I call these to be the categories, okay, I can tell how many times Delhi word has come up in a particular document, say 100. I have a document, okay, how many times the word Delhi has come in this document? It could be 100. How many times Mumbai came up? Say 50. Pune came up 20 times. So these are the frequencies of the word Delhi, Mumbai, and Pune. So I can only do the mode of the nominal data. Okay, other than this, I cannot do any mathematical operation. Now, when it comes to the ordinal, what happens? In the ordinal, I can do whatever I have done in the nominal category. There will be one additional quality in the ordinal is I can do some comparisons. I can do some relativity. For example, small, medium, and large. Now you know small, medium, large cannot be added up, cannot be divided, cannot be summed up. But one thing I know that small will always be less than medium, medium will always be less than large. So there is some kind of relativity available. So in the ordinal data, it will be having all the characters of the nominal, plus there will be one additional character of relativity. So if someone asks you what is the difference between nominal category and ordinal category, or nominal data or ordinal data, so you will be saying that nominal data cannot have any mathematical operation. Only analysis I can do is calculate their frequency. While in the case of ordinal, I can do all those analysis I can do in nominal, like frequency analysis. In addition to it, I can uh, compare the relativity between the different categories. For example, small, medium, large, suppose there are three categories. So I can say small is less than medium. Okay. And suppose if I say short and tall, tall is more than short. But you cannot tell how much tall or how much short, how much is the difference. Small minus medium, this is not making any sense here. Okay. So try to figure out examples from your side. What are the examples you are saying are actually the nominal data, ordinal data. Okay. Now coming to the second type, that is the quantitative. Quantitative data are those data where I can apply these mathematical operations, plus, minus, multiply, divide. But can I apply these mathematical operation in all the types of data? Answer is no. So there are further two subdivisions of the quantitative data, that is discrete and continuous. So I will be starting with the discrete. So what does the discrete says? Discrete means I can do only plus and minus. Okay, multiplication and division, these two operations are not allowed here, only plus minus is allowed. Okay, and if I say continuous, in the continuous, plus, minus, multiply, divide, all these four operations are allowed. But in the case of continuous, there will be one check, that it has two subdivisions. One is interval and one is ratio. In the case of interval, I cannot do multiply and divide. Multiplication and division, in addition to plus and minus, can only be done in the case of ratio types of data. Now, what is the interval? What is ratio? Okay, for the example, the discrete, if I roll a die, okay, it has this four number, I can get the result 1, 2, 3, 4, 5, and 6. Okay, so I can do the plus minus here. Okay, but I cannot do the division here in this case. So it is a discrete data. Okay, again, when I'm saying that I can do the plus minus, that is means suppose if I say what is the probability that I am rolling a die, the sum of the top face is coming to be 3. Okay, so I am rolling 2 die. Okay, so what is the probability that the summation of the top face is 3? So it could be 1, 2. Okay, it could be 2, 1, and nothing else. So I am adding up these results. Okay, and here I can never get a result like 1.5. I'm rolling 1 die or 2 die, so I'm getting a result say 1.5. No, either I will be getting 1, 2, 3, 4, or 5. There is no sense of any number 1.5 in rolling a die. Okay, so it is a case of discrete. Means I am capable of doing mathematical operation on these numbers of plus and minus, but 1.5 or any number in between these two categories does not make any sense. If the numbers are of that type, so it will be coming in the case of category, discrete type. Okay, now coming to the continuous. Continuous, as the name is suggesting, it is continuous. Okay, there is no gap. Suppose I have an interval, say a to b, so it is continuous. All the values which can be possible between a and b are existing. Okay, there is no such problem like of discrete. But situation is, in case of interval, I will be telling one thing of absolute zero. This term you should understand. Absolute zero means, uh, if zero means the absence of anything. Okay, Suppose if I say there are 0% in the room, it means there are no person in the room, means the absence of people is there. Okay, but sometimes if I give 0 as an identity of something, okay, if I give 0, if 0 does not mean the absence of anything, so in that case what will happen, that will not okay, let us take an example of temperature. That is the very standard example you will be finding in many of books. Temperature, if I say 0 degrees Celsius, does it mean the temperature is absent? No, it means temperature is there and the intensity of the temperature is 0 degree, okay, on degree centigrade. It does not mean temperature is not there. The absence of temperature, it does not mean the absence of temperature. It means 0 here in this case does not imply the absence of temperature. Rather, 0 degree centigrade is actually telling something, okay, this thing is very cool. Okay, so this is not the case of absolute 0. Suppose I say if I have 0 pen, what does it mean? It means I do not have any pen. Is this 0 pen means absence of pen. Okay, so if this is the absolute 0 means when 0 actually means the absence of something or absence of anything. Here this 0 does not mean the absence of temperature. So it means when the absolute 0 is there in the continuous data, so it will be coming as a case of ratio. When absolute 0 is not there in the data, although the data is continuous, so it will be a case of interval. Now see, I take a temperature, say 1 degree and 2 degree. Now 1.1 degree, 1.2 degree, 1.3, 1.4, all this temperature can exist. Okay, if I say 0 degree, this will also exist. But 0 degree does not mean the temperature is absent. It means temperature is there and the intensity of temperature is 0 degree, and that has some meaning. Okay, so this kind of data, okay, cannot be divided. I cannot divide 2 degree divided by 1 degree. Means it means I cannot say the effect of heat. I cannot say that if the temperature, say one object is 2 degree Celsius, the temperature of another object is 1 degree Celsius. I cannot say this object is 2 times hotter than this object whose temperature 1 degree Celsius. I cannot make these statements in case of temperature. Okay, why? You can take it as a hint that when the absolute 0 concept is missing in the accounting of that data, so we cannot do the multiplication and division operations. If we cannot do it, so we cannot tell the or compare the numbers in terms of factors of one another or ratio of one another. And the ratio can only be uh, compared when the data is making sense with absolute 0. For example, marks in mathematics. One person can get the mark 0. It means he did not score anything or she did not score anything. Okay, so that is the ratio category. Now, the thing is, if I have to do some analysis, so maximum information I can get from the ratio type of data. Okay, this is not the type of data. This is the measurement of scale. If a data is of ratio type, then that will be giving me the maximum information about the data. Okay, I can generate maximum inferences from this data. If the data is of interval type, then again I can do a lot of analysis here as well, but the relative information, the relative uh, 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 say analysis will be lesser than the ratio. Means the more information I can get from the ratio type of measurement, and interval measurement will be having lesser information compared to this. Similarly, in case of nominal and ordinal, ordinal is having more information. Ordinal data is giving me more information about the data about means the analysis. Okay, compared to nominal. If I draw a chart, simple chart like nominal, ordinal, interval, and ratio. So this is the level of information. Okay. So ratio gives me the maximum information. Interval gives me the lesser information. Ordinal gives lesser, and the least information is coming from the nominal. Okay. So this thing you should keep in mind. And this is the continuous data. Okay. Now the recruiter can ask you questions like, what is the difference between the qualitative variable or qualitative data or quantitative data? This you can prepare. And when is each appropriate or important? Okay. Now these are the questions you have to prepare from interview point of view. Okay. You are not required to solve any numerical on it. You should be able to give one example from your life, from your experiences about, okay, these are the data I think should be coming in the qualitative variable, quantitative variable. Like here, we saw the example of marks in mathematics, temperature, dice, names of the cities. Okay, these are different examples we use. And similarly, you can generate your own examples of the qualitative variable and quantitative variable. And what is the difference between discrete and continuous variable? Okay. And under what circumstances is each applicable? What are the circumstances? Okay, so the circumstances means how will you find, okay, I should apply uh, the the data I should collect should be of discrete type of continuous type. So what are those conditions? Okay, you should prepare these conditions from your experiences. Means suppose you worked in a startup, you worked in any MNC, or if you are a fresher, then I would advise to take any one or two subjects where statistical understanding can be applied. Okay, so you can convince other person that whatever, although I'm not coming from the statistics background, I'm not coming from the analytics background, but I have understood how the stats, machine learning, analytics can be applied in the field where I have studied, I have invested time till date. Okay, and that is my inspiration to join into this course. So in this way, you can frame your sentences. Now, this question, uh, try to take some inspiration from this question and formulate 5 or 6 types of different types of questions based on it. Restaurants sometimes provide customers reaction cards so that customers can evaluate their dining experience. Okay. These customer reactions can be in the form of 1 star, 2 star, 3 star, or they can be in the format of a smiley. Okay. So what kind of decisions might be made based on this information? Okay. So what kinds of decisions you can find? Okay, out of 1,000 customers, uh, say 500 customers are giving me poor smiley, 700 customers are giving me that smiley, 300 customers are giving me that smiley. Okay, these kind of analysis, and and you can do, and based on those analysis, what decisions can you make? Okay, many of our customers are actually not happy, many of our customers are happy. This kind of decisions you can give. What type of statistical data play a role in auto insurance company? Okay. So in auto insurance company, what happens? I have to decide the premiums. Okay, premiums based on what? The probability of means I will be classifying the automobiles in an order of probability of getting a probability of asking claim. If there are more probability that a particular auto is likely to ask for a claim, I will be charging them higher premium. Okay, similar case, you can go with the health insurance. Suppose if a person who is having some comorbidity, like suppose a person is having lungs issue or someone is having heart related issue, if that person is going for the health insurance, the premium of that person will be high. Why? Because there are more chances of him going for the hospital and getting admitted, getting the treatment. So insurance company will be charging more premium from him or her. In comparison to this person, if a person who is completely fit and fine is getting the insurance, the premium will be lesser here. Okay, so what types of statistical data play a role? Okay, so this you can try to formulate by yourself. and you prepare these results, these answers, and share the answers with me. I can help you in polishing your answers. But these are the ways. If you do, you will be understanding the process of interview. Okay. Similarly, a fifth question, and based on this, you can prepare your own questions. You can take the help of ChatGPT and other online places as well, if you wish. But I have given you a basic template. Okay. Now we are being left with the visual description of data. So visual description, I'll uh, explain it quickly. The line chart. Okay, I'll do one thing. I'm pausing the class till here. I will be coming with the visual description tomorrow. Okay, I will be explaining these 5 different charts. Okay, and their differentiation between these charts. And I've also prepared some questions based on these charts that can be asked. Again, these are here only for the inspiration. I will advise that understand the general concept, basic concept, understand what kind of questions can be asked, and try to prepare your own question bank as well in parallel to it. Okay, so I will be giving you the description of this visual line chart, histogram, bar chart, pie chart in tomorrow's session. So till today, we have completed the type of variables. Okay. Again, if you are following any book or anything, they actually, the statistics is a technical subject. It is being taught like a mathematics, solving problem, giving formulas, deriving formulas. But we are preparing for PGDB interviews. So we have to understand things from the applied side. Although we will be needed to do some analysis and calculation, but that will not be very complex. Okay, the PGDB interview will be of say 15 to 20 minutes roughly. So they will be giving a max to max 1 or 2 numericals if they want you to solve it. Okay, and that will not be very complex. So we will be covering everything, but from perspective that a person who is coming in the who's coming to take your interview is able to, means he is getting convinced, okay, this person is having some interest and having some understanding about the subject. Okay, so this is for today only, and we'll be finishing I think in about 8 to 9 lectures the whole stats, keeping in mind what is being asked in the PGDB interview. Okay, so thank you for today's session. If in case of any doubt, just tell me. Okay, you are having contact details, and do share me your answers, and let us make it more polished, more mature, more professional, so that that can be spoken in the interview being asked. Fortunately, thank you. All the best.